Every Linux system, no matter how well maintained, will eventually have weaknesses. And knowing how to find and fix them is one of the most valuable skills in IT security. In this short course, we'll walk through the complete vulnerability management workflow from the moment a flaw is published as a CVE to the day it's patched on your servers. Along the way, you'll learn how vulnerabilities are scored on a 0 to 10 scale, the repeatable 5-step cycle that ties it all together, and the free open source tools that make it possible. Here's the path we'll take together. We'll start with the fundamentals, what a vulnerability actually is and why it matters, then learn the shared language security teams use. Terms like CVE, CVSS, CWE, and the NVD. From there, we'll walk through the 5-step management cycle, look at the free scanners that bring it to life, and explore how to prioritize fixes based on real risk. We'll close by turning all of this into a lasting habit, supported by policy, automation, and the right metrics. So let's start at the very foundation. A vulnerability is simply a weakness in software, in configuration, or even in hardware that someone could exploit to do something they shouldn't, like reading private data, gaining access, or crashing a system. It might be a coding flaw like a buffer overflow, a misconfiguration such as a default password left in place, or an outdated package with a known fix already available. And it's worth separating 4 ideas right away. The vulnerability is the weakness itself. The threat is who might exploit it. The exploit is the actual attack code, and the risk is the likelihood times the impact. Now, why does this matter so much on Linux specifically? Linux quietly runs most of the internet, web servers, cloud workloads, containers, even the smart devices in your home. So, a single unpatched flaw can ripple across thousands of systems at once. These machines are reachable around the clock. Every installed package adds to the attack surface, and the moment a CVE goes public, attackers see it too. That's why speed matters. Working exploits often appear within days of disclosure, sometimes hours. Before we go further, let's get 4 key terms straight. You'll see them everywhere in this field. A CVE is just a unique ID for a single flaw, like ZVE 2024-1234. CVSS is the score attached to it from 0 to 10, telling you how dangerous it is. CWE describes the type of weakness. For example, CWE 79 is cross-site scripting, and the NVD is the US-run database where all of this comes together, scored and detailed. Lock these in because we'll lean on them constantly from here on. Now let's zoom in on that CVSS score and learn how to read it. The scale runs from 0 to 10, split into 4 bands. Anything under 4 is low, fix it when you get around to it. 4 to 7 is medium, worth planning in. 7 to 9 is high, so move quickly, and 9 and above is critical. Drop what you're doing and patch. But remember, CVSS measures severity in general, not your specific risk. A critical bug on a disconnected test box matters far less than a medium one sitting on a public-facing server. With severity under our belt, let's step back and see the bigger picture. The 5-step cycle that turns all this theory into practice. First, we discover what we own. Then we scan it for flaws, prioritize those flaws by real risk, remediate by patching or mitigating, and finally verify the fix actually worked. And here's the key word, continuous. After verify, you loop straight back to discover because new assets appear and new CVEs are published every single day. So let's begin at step 1. Discover. The simple truth is, you can't protect what you don't even know exists. That means listing every host, servers, virtual machines, containers, even IoT devices, then inventorying the packages on each one with tools like dpkg, L or RPM-QA, and mapping which services are listening using SS, tulpa-in. And because inventories drift the moment you finish them, automate this. Don't do it once, do it continuously. With our inventory in hand, we move to step 2, scanning. A scanner takes that list of installed software and compares it against known vulnerability databases, flagging anything that matches. You've got three flavors to choose from. Authenticated scans, which log in and check versions for the most accurate picture. Network scans, which probe from outside to show you what an attacker would see. And agent-based scans, where a lightweight process on each host reports continuously. To start simple, just run apt-list, upgradable on Debian or Ubuntu, or DNF update info list security on RHEL. That's already a basic scan. Once the scan finishes, you'll likely be staring at hundreds, even thousands of findings, which brings us to step 3, prioritization. The trick is to weigh 4 things together. Severity gives you a starting score through CVSS, but on its own, it's not enough. Combine it with exploitability. Is this flaw actively being abused in the wild, as tracked in SIA's known exploited vulnerabilities list? Then layer in exposure. Is the system reachable from the internet or tucked safely inside? And finally, asset value. How much does this machine or its data actually matter to the business? A medium severity bug on a public database often beats a critical one on an isolated test box. To make that weighing concrete, picture a simple 3x3 grid. Likelihood across the bottom, impact up the side. Anything landing in the red corner, high likelihood and high impact, is your critical fire to fight first. The green cells in the bottom left can comfortably wait for your next routine patch window. It's a quick visual gut check that keeps your team focused on real-world risk, rather than chasing every high CVSS number on the list. Once we know what to prioritize, step 4 is to actually do something about it. And you've got 3 honest options. Patch is the gold standard. Apply the vendor's fix and the flaw is gone. When you can't patch right away, mitigate. Close the exposed port. Disable the risky feature or block it at the firewall to shrink the attack surface. And sometimes you accept the risk, documenting why a fix isn't practical today. And whichever path you choose, test in staging first and keep a rollback ready. A broken update can hurt more than the bug itself. Since patching is usually our first choice, let's see what that actually looks like on Linux. On Debian or Ubuntu, it's apt update and apt upgrade, and you can automate security fixes with the unattended upgrades package. On Red Hat or Fedora systems, DNF upgrade with the security flag narrows things down to just security-relevant updates. For the kernel itself, tools like Kpatch and Ksplice can apply fixes live without a reboot, handy for servers that need to stay up. And for containers, don't patch a running one. Rebuild the image from an updated base and redeploy it cleanly. And that brings us to step 5, verify. Never just trust that a patch worked. Run the scanner again and confirm the finding is actually closed. While you're at it, check that the fix didn't break a service or quietly open a new gap, and write down what you did, what you found, and when. Your future self and your auditors will thank you. Then loop straight back to discover, because new CVEs appear every day, and this cycle never really ends. Now that you understand the cycle, let's talk tools. And the good news is, you don't need an expensive license to begin. OpenVAS gives you a full vulnerability scanner, Trivy handles containers and images, and Linus audits the host itself for hardening gaps. On the code and network side, OSV Scanner spots vulnerable dependencies in your projects. Nmap, with its scripting engine, covers discovery and basic checks. And don't forget apt or DNF. Your own package manager will already tell you which security updates are waiting. With your toolbox ready, let's pause on the traps that catch almost every newcomer. Scanning once and walking away gives you a snapshot, but new CVEs land daily, so yesterday's clean report means little today. Chasing only criticals is another classic mistake. A medium severity flaw on an internet-facing server often beats an isolated critical buried deep inside. Patching without testing can break production worse than the bug itself. And finally, if you have no inventory, assets you don't know about will never be scanned and never be fixed. And that's exactly why the next step is automation, making vulnerability management a habit, not a fire drill. Schedule your scanners to run daily or weekly so you're never relying on memory. Let tools like unattended upgrades quietly handle the low-risk patches in the background. Pipe critical findings straight into Slack or email so nothing slips through, and track your open vulnerability count over time. When that number trends down, you're winning. And to know whether automation is actually paying off, you need a few simple metrics. Mean time to remediate, or MTTR, tells you how quickly you fix flaws once you found them. Ideally, that number shrinks over time. Open vulnerabilities by severity shows your remaining workload at a glance. Coverage reveals your blind spots. Any asset you're not scanning is one you can't protect. And SLA hits answer the key question: are your critical patches landing inside the deadline you promised? So let's pull all of this together into a starter checklist you can act on this week. Begin by inventorying every Linux host and the packages they run, then pick one free scanner and launch your very first scan. Review the findings, sort by CVSS score and real-world exposure, and enable automatic security updates wherever it's safe to do so. Patch your criticals quickly, but always test before production. And finally, rescan to confirm the fix held, then put that whole cycle on a schedule so it repeats. And that's really the heart of it. Vulnerability management isn't a one-off project you finish and forget. It's a continuous habit. Discover, scan, prioritize, remediate, verify, then start the loop again. Done consistently, those 5 small steps are what keep Linux systems genuinely secure over time. If you'd like to go deeper into Linux hardening, DevOps, and cybersecurity, head over to dargslan.com for courses, cheat sheets, and CLI tools. And if this helped, subscribe, like, and share. Thanks for spending this time with me.